Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, Scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, This next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Across millennia, scattered among clay tablets, sacred scrolls, and whispered myths, humanity has preserved haunting tales of a celestial anomaly, a rogue planet, a cosmic saboteur whose rare appearance heralds disaster and upheaval. The Sumerians called it Nibiru, the planet of crossing. Egyptians feared it as the destroyer. Biblical texts knew it as the wormwood star. Are these merely the colorful myths of ancient peoples, or are they fragmented memories of an all-too-real cosmic threat? Modern science, once quick to dismiss such legends, is now forced to reconsider. In 2016, astronomers Konstantin Batygin and Mike Brown from Caltech presented mathematical evidence suggesting the existence of a massive planet at the far edge of our solar system, Planet 9. Their calculations describe a world 5 to 10 times the mass of Earth, on a highly elongated orbit that takes between 10,000 and 20,000 years to complete a single revolution around the Sun. Here's where ancient myth and modern astrophysics begin to blur. Sumerian cuneiform tablets, dating as far back as the 4th millennium BCE, contain astonishingly accurate astronomical data. They describe a solar system of 12 celestial bodies, including a mysterious 12th planet, Nibiru. How did ancient people know about Neptune, discovered only in 1846, or Pluto in 1930? Were they simply guessing, or did they remember something we've forgotten? One of the most controversial voices in this debate is researcher Zecharia Sitchin. He spent decades interpreting ancient Mesopotamian texts and proposed a radical theory that Nibiru is a habitable world with a sweeping elliptical orbit, home to an advanced race known as the Anunnaki, beings who once visited Earth. Mainstream academia has rejected Sitchin's translations, but the uncanny parallels between his claims and recent astronomical findings are hard to ignore. Let's focus on what the data tells us. Something is warping the orbits of distant objects in the Kuiper Belt, a vast icy region beyond Neptune. These objects behave as if being shepherded by a massive, unseen force. The dwarf planet Sedna, for example, follows a wildly unusual orbit that can't be explained by known gravitational influences. And then there's the Kuiper Cliff, an abrupt drop-off in the number of objects beyond 50 astronomical units. What's causing it? Something or someone. These anomalies have left astronomers scratching their heads and have fueled growing speculation that a massive, unseen planet is hiding in the dark outskirts of our solar system. Ancient texts from multiple civilizations describe apocalyptic upheavals linked to a celestial intruder. The Egyptian Ipuwer papyrus eerily recounts plagues and chaos. The river is blood, the earth turned upside down, days are shrouded in darkness. The Babylonian Epic of Era speaks of a time when the stars left their appointed paths. These aren't just poetic metaphors. They're historical shockwaves echoing from a forgotten trauma. So what happens if Nibiru, or Planet 9, makes its next approach? Even without a direct collision, the consequences could be catastrophic. Its gravity might tilt Earth's axis, triggering sudden climate shifts. It could awaken tectonic fault lines and stir dormant volcanoes. Disturbed asteroid belts might send deadly space rocks hurtling toward us. It could disrupt our magnetosphere, disabling electronics and satellites. But perhaps the most chilling aspect of this theory is the cycle. Sumerian texts suggest that Nibiru returns roughly every 3,600 years. If this is true, its last passage might have occurred around 1600 BCE, a time curiously aligned with the collapse of Bronze Age civilizations, a period marked by mass migrations, natural disasters, and inexplicable cultural decline. Was this coincidence or consequence? The clock might be ticking again. Today, the hunt for Planet 9 continues, using the world's most powerful telescopes and cutting-edge simulations. We stand on the edge of either confirming the greatest myth ever told, or revealing that ancient peoples tried, in the only language they had, to warn us. It may not bear the name Nibiru. It may not carry golden tablets or alien emissaries. But if it exists, its return will reshape everything we think we know about history, science, and our place in the cosmos. One thing is certain, our solar system is far from tamed. It harbors secrets in its coldest, darkest corners, riddles older than civilization itself. And perhaps, just perhaps, the old stories were never stories at all. Maybe they were prophecies. Maybe they were the echo of survivors. Maybe the star of change is already on its way.
An invisible star, a red dwarf, hides 124 light-years away from us. And orbiting this faint celestial body is a planet that could fundamentally alter our understanding of life in the universe. Its name is K2-18b, and this is not its first time in the scientific spotlight. But now the reasons are far more compelling and perhaps historic. A team of astrophysicists from Cambridge, working with data from NASA's ultra-sensitive James Webb Space Telescope, has discovered chemical compounds in the planet's atmosphere that, on Earth, are produced exclusively by living organisms. The substances in question are dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. On our planet, these gases are typically associated with marine plankton and certain bacteria. What they are doing in the skies of a distant exoplanet is still a mystery, but a mystery that might point toward extraterrestrial life. Professor Niku Madhusudan, the lead researcher on the project, calls this the most convincing evidence to date of potential life beyond Earth. If our interpretation is correct, he says, we could confirm it within a year or two. Perhaps the most astonishing part of the discovery is the quantity. The concentration of DMS found in the atmosphere of K2-18b appears to be thousands of times higher than equivalent levels on Earth. If this is not a mistake or observational artifact, we may be looking at an entire world teeming with life. But scientists, including Madhusudan's own team, urge caution. The current data, while impressive, still falls short of the rigorous standards required for a formal scientific discovery. To claim definitive proof, they need a statistical confidence level of 99.9999%, known as the 5 sigma threshold. At present, the result stands at 3 sigma, or 99.7%, a significant improvement from previous estimates of 68%, but still not enough. Other researchers and independent experts echo the cautious tone. Astronomer Catherine Hamans, for instance, emphasizes that even with reliable data, we cannot say with absolute certainty that DMS and DMDS originate from biological processes. The universe is vast and filled with exotic phenomena. We still don't fully understand what can happen inside such alien worlds. The intrigue surrounding K2-18b isn't based solely on its mysterious chemistry. The planet is roughly 2.6 times the size of Earth, and data suggests it has an atmosphere where ammonia is notably absent, a gas that should be present in a dry, oceanless world. This absence points to a compelling hypothesis: the presence of a vast subsurface ocean. And where there's water, the possibility of life follows. However, alternative scenarios remain. The ocean might consist not of water, but of magma, a revelation that would crush hopes for life. Adding complexity, the planet's very structure is under debate. Some models describe K2-18b as a mini-gas giant with no solid surface. That would render the world utterly inhospitable to life, at least any form of life we currently comprehend. Still, despite all the ifs and buts, the scientific community remains deeply intrigued. The Cambridge team is collaborating with other research institutions to investigate whether the detected molecules could be synthesized through non-biological means in laboratory settings. If such synthesis proves impossible, the case for a biological origin becomes far stronger. Professor Subir Sarkar, another member of the project, is careful with his conclusions, yet he acknowledges that the possible presence of an ocean makes K2-18b one of the most promising candidates in the quest for alien life. His message is simple and clear: watch this space. Cambridge astrophysicist Oliver Shortall, however, brings us back to reality. He reminds us that all of our knowledge about distant exoplanets is drawn from faint threads of light passing through their atmospheres. Interpreting those signals is like trying to read a smudged and half-burnt map, prone to error, to bias, to misinterpretation. Each promising signal could be either a whisper of life or a trick of the cosmic light. Yet the implications are impossible to ignore. Even the slightest probability of a biological origin for these gases elevates the conversation. This isn't just about chemistry. It's about existence. About the possibility that we may not be the only ones looking up into the void. Public curiosity has surged alongside scientific interest. News of K2-18b's chemical profile has lit up headlines, podcasts, classrooms, and conspiracy forums alike. Some hail it as our first real evidence of alien life. Others urge restraint, cautioning against the seduction of sensationalism. But in a world starved for wonder, K2-18b delivers, even if only as a promise. Further missions are already being drafted. Telescopes in space and observatories on Earth are preparing to lock their gaze on this distant enigma. New instruments, refined spectrographs, and smarter algorithms will seek to strip away more layers of the mystery. Every spectrographic fingerprint, every spectral dip in starlight brings us a little closer to confirmation, or recalibration. Science moves not with leaps of faith, but with patient, deliberate steps. And yet, some steps feel bigger than others. When we look at K2-18b, we don't just see another planet. We see a question written across the stars: are we alone? As Madhusudan puts it, decades from now, we may look back at this moment and realize it was the beginning, the dawn of a new cosmic chapter. The moment humanity first saw the glimmer of a living universe beyond the solar system. The discovery hasn't been made yet, but the journey has begun, and that alone is already extraordinary.
A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star where the temperatures on the planet should be okay-ish and water should stay liquid on its surface. It's not super precise because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range, they actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
On a cold January night in 1978, 2 neighboring military installations, Fort Dix Army Base and McGuire Air Force Base in New Jersey, became the stage for events that might have forever altered our understanding of extraterrestrial presence on Earth. Known as the Fort Dix incident, this case remains one of the most enigmatic and heavily classified stories in military UFO encounters. A quiet night, shattered by the unexplained. Around 3 a.m. on January 18, 1978, Security Patrol Officer Sergeant Jeffrey Morse was conducting a routine perimeter check at McGuire Air Force Base. Everything seemed normal until radio chatter reported unidentified flying objects hovering over nearby Fort Dix, moving in tight formation and emitting an eerie bluish-green glow. Radar operators soon confirmed the anomaly. These objects maneuvered in ways no known aircraft of the time could. They hovered, changed direction abruptly, and vanished from radar screens as if toying with their observers. A close encounter turns violent. By 3:30 a.m., the situation escalated dramatically. A military police officer at Fort Dix, patrolling a remote section of the base, radioed that an oval-shaped object with no visible features had descended over his vehicle. Suddenly, a humanoid figure, about 4 feet tall, with grayish-brown skin, an oversized head, and elongated arms, appeared in front of him. Panicked, the MP drew his sidearm and fired 5 rounds into the being, followed by a 6th shot at the hovering craft. Immediately, the UFO shot upward and vanished, while the wounded creature fled toward the fence separating the two bases. The cleanup operation. Within minutes, a team of unidentified soldiers in blue berets, with no insignia, arrived, cordoning off the area and pushing back regular personnel, including Morse. Witnesses later described how the team sprayed the body with an unknown substance, covered it with a white sheet, and placed it inside a large metallic container marked with blue symbols. By dawn, the container was loaded onto a C-141 cargo plane bound for Wright-Patterson Air Force Base, a facility long rumored to house classified UFO-related materials. Aftermath: enforced silence. 2 days later, Morse and other witnesses were flown to Wright-Patterson for interrogation. In a stark room facing 3 men, one a silent civilian with a pipe, Morse was forced to sign a lifetime non-disclosure agreement. Soon after, all involved personnel were reassigned to overseas bases, effectively scattering them across the globe. Morse was sent to Okinawa, Japan, where he spent 2 years before finally breaking his silence. Fact or fiction? In 1980, Morse reached out to UFO researcher Leonard Stringfield, sharing his account. His story gained credibility when Major George Fuller, an intelligence officer stationed at McGuire, confirmed unusual activity that night, mentioning that something was found dead on the runway, though details were withheld from him. Skeptics argue the incident could have been a test of a military biodrone or experimental entity, a psychological operation, PSYOP, to study human reactions, an elaborate hoax or misidentification, yet the military's extreme response, immediate witness isolation, rapid evidence removal, and lifetime gag orders suggest something far more extraordinary. Conclusion: a secret still waiting to be uncovered. Over 45 years later, the Fort Dix incident remains buried in secrecy. If Morse's account is true, this could be the first documented case of military personnel killing a potential extraterrestrial being. Until classified documents surface, key questions linger. Was this a genuine extraterrestrial encounter, or an elaborate cover-up for advanced military technology? One thing is certain: that night in 1978 changed the lives of those involved and left behind more questions than answers. What do you think? Could this really have happened? Or is it just another military urban legend?
At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of two more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our Sun's companion star. According to this theory, the Sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the Sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaeton's was a good story, it's not popular anymore.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9. a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, is still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on the super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
We've discovered Kepler 22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler 22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler 22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler 22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler 22, the star of Kepler 22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler 22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler 22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler 22b is that it's about 15% closer to its star than we are to the Sun. If Kepler 22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler 22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler 22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler 22b can rotate around its star on its side, like, for example, Uranus. What? didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called IRAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both IRAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper Belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact, if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars, But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the Moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the Moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our Sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that? Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TESS 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TESS 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TESS 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TESS 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blow-torched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets, but Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth, in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system.
More than 20 years ago, back in 1999, we discovered an interesting diamond-shaped space rock. It was an asteroid called Ryugu. Its name is the Japanese term for Dragon Palace. There's a Japanese folktale behind that name. Basically, it's about a magical palace hidden deep underwater. In this story, there's a fisherman who visits the castle traveling on the back of a turtle. He returns back to the surface with a mysterious box. About 2 years ago, a similar thing happened in reality when the Japanese spacecraft Hayabusa 2 visited Ryugu and came back with mysterious samples it picked up there. And the fairy tale doesn't just stop there. There are so many craters and rocks on Ryugu, so it probably had quite a rough past. And the craters all share a theme. They're named after something from the world of fairy tales. For example, the name of the princess who lived in this magical Ryugu castle, together with her dad, a dragon deity. Some got names after the fisherman who saved a turtle, and the turtle itself, of course. But back to the science now. So this spacecraft took a sample from the surface of Ryugu, got back to Earth, and teams of researchers discovered something really cool. The asteroid is even older than our solar system. The spacecraft took the sample to help researchers to understand the origins of our solar system better. But this is not the first time scientists came across such ancient grains. They previously found them in multiple meteorites. Meteorites are generally space rocks that survive the fall through the atmosphere to land on Earth. They're usually rich in carbon, just like the asteroid Ryugu. But the material on Ryugu is even more specific and something you can't stumble upon on our planet: silicon carbide, a combination of pure silicon and pure carbon. The material Ryugu is made of is so unusual, it even tells us the asteroid was formed in the outer solar system. It's one of the 3 asteroids that are orbiting the Sun, but are moving relatively close to Earth. Each of them is just a loose pile of rubble, and their collective gravity is something that holds them together. They probably formed after their parent bodies collided and shattered into smaller pieces. Ryugu's individual rocks are probably 4.6 billion years old, or even more. So, it's most likely made up of material from its parent body. But some theories claim its surface could be 158 million years old. Ryugu sneaked into the inner part of our solar system, so we got a better chance to study it a little bit. It's circling around the Sun somewhere between our home planet and Mars. It crosses Earth's orbit from time to time, which is why it ended up in a category of potentially dangerous things for us, even though it's peaceful at the moment, and it really doesn't harm us in any way. It's one of the darkest space bodies in our solar system, and it's surprisingly dry. Strange, its parent body probably consists of lots of water ice. Maybe Ryugu is dry because it has flown too close to the Sun sometime in the past. That heated up its surface and dried it out. Or some of its radioactive materials heated the asteroid and removed most of its water. How do we even know how old our solar system is? Once upon a time, which is billions of years ago, in some faraway, almost forgotten corner of the Milky Way, there was a molecular cloud. It fell apart and collapsed like many others across the universe did. That's how new stars form. This one formed new stars too, and one of them was a little bit isolated from the others. It collected material around it and turned it into something we call a protoplanetary disk. That's a disk of gas and dust that rotates and goes around the core of what will later become a solar system. That disk can develop into celestial bodies too, like asteroids and planets. But this disk formed the central star we know today as our Sun, 8 planets, and the rest of the objects that make our solar system. It's about 4.6 billion years old. All stars come from this pretty cool thing called a pre-solar nebula. It's, once again, a cloud of dust and gas that pulls material in. Later, a star forms out of it. A big outer region that surrounds a nebula is cold. A pre-solar nebula creates a protostar. It's a young star that is still not on its own, but needs to gather mass from its parent cloud. Then the star becomes independent. The material from the outer cold region then starts forming bigger clumps. As time goes by, these large clumps grow and fall in. They move around, interact with each other, and sometimes even merge or eject one another. After hundreds of thousands to even millions of years, once there's a star, the planets start forming. There were probably many objects that are gone by now, but our solar system doesn't look very different from what it was back when it was formed. Some things may have been different though. We have 4 gas giants now. Jupiter, Saturn, Uranus, and Neptune. Maybe there might have been a fifth one too. It's possible our 4 gas giants were closer to the Sun, but they migrated outwards. And what was between Venus and Mars? One theory says Theia, a smaller Mars-sized world that later, bam, collided with Earth, and we got the Moon. Checking the materials of these objects, scientists have found out many interesting things when they study all kinds of minerals, rocks, and solid bodies. The composition of different elements tells them about how old some object is. They have studied meteorites that have landed on our planet. They assumed these meteorites and the Earth are part of the same system, so they calculated their potential age and got around 4.54 billion years. Rocks from the Moon haven't gone through the same processes as Earth rocks, and they're younger by a couple of million years. And the Sun, the central star of our solar system, could be a bit older, maybe tens of millions of years older than the oldest rocks. That's how formation in most cases goes, remember? Stars first, then planets and other solid objects next. So yes, it could be close to 4.6 billion years old. Jupiter's satellite Callisto is, as far as we know, the oldest moon both in our solar system and the universe. It's not that glamorous, just a rocky world with ice covering its surface and many craters. These craters tell us that many random flying objects have been hitting it over the past 4 billion years. That's how long we believe it's been around. Callisto and the rest of the moons around Jupiter have probably been born out of debris that was left after Jupiter formed. This all seems so old, but the universe is 13.7 billion years old. So imagine how many things out there are even older than our solar system. But now, scientists have confirmed that they have found one of the oldest but also most distant objects we've ever known in the universe. It's a galaxy 12.8 billion light years away from us. It started forming within the first billion years of the universe, which also means it was that long after the Big Bang started everything. During the first 400 million years after the Big Bang, it was most likely way too hot for anything to form. So, first galaxies, black holes, and stars started forming maybe within the first 500 million to billion years. So this old galaxy could be one of the first things that ever appeared in the universe, and we get to see it. It's hard to observe it though. Scientists use a telescope to explore it, but the picture's still very blurry. It's hard to see such objects because of all those thick, gigantic clouds of dust that surround them. The Hubble Space Telescope is usually best to view distant galaxies. But there's another telescope with a better position to look at such objects, and we can't wait for it to be fully operational to see what else it'll discover.
Whoosh! Debris runs through outer space all the time, often heading towards our planet. We're mostly not aware of it. Most of that debris burns up when it enters our atmosphere anyway. We do get to enjoy the bright blaze in the clear night sky because, from time to time, we see it as fleeting meteor showers. But sometimes, a meteorite is tough enough to survive the atmosphere and large enough to leave a remarkable spot on our planet. We're talking about what often looks like nearly circular excavated holes. Nestled in the Colorado Plateau in northern Arizona, Barringer Crater is a rimmed pit in the shape of a bowl we also call Meteor Crater. It's relatively young since it formed only 50,000 years ago. There was this enormous iron meteor that hit at eye-watering speeds of up to 26,000 miles per hour. It exploded so hard that the meteorite excavated an amazing 175 million tons of rock. Daniel M. Barringer first identified this crater. He strongly believed the pit was a result of a meteor hitting our planet, but not many scientists believed him. Barringer spent a couple of years investigating this crater to prove his theory. Not just that, he also hoped to find some of the valuable metal content. But a major part of this once pretty large meteorite would have been destroyed during the collision. Kali Crater. At first, it seems like you're looking at a nice swimming pool. But 7,500 years ago, another meteorite headed towards the Earth. While passing by through our planet's atmosphere, it fell apart and hit our planet in fragments. That's how Kali meteorite crater field formed. A group of 9 meteorite craters in the Estonian village of Kali. That's located on one of the country's islands. The largest crater ended up being 360 feet wide and 72 feet deep. The rest of the 8 smaller holes are located right around the main one. It's a tourist attraction today. But imagine how panicked our prehistoric ancestors that lived there must have felt while watching these gigantic rocks fall from the sky. Also, there's a chance the surface of this island was covered in forest. But it all probably burned down during the impact. South Africa has its own gem too, Fort Crater, the largest and the oldest one in the world. More than 2 billion years ago, a meteorite with a diameter of 6 miles struck our planet close to today's Johannesburg, South Africa. This impact was nearly twice as powerful as the one that made the dinosaurs go extinct. Almost right after the meteorite hit the ground, the crater formed. The hole shallowed and widened as the rock below began to rebound, plus its walls collapsed. The meteorite that hit this spot was probably 6 to 9 miles in diameter. If a celestial object that hit the Earth is bigger than 0.6 miles, it could have effects on the global level. So this one probably caused fires across the world. Also, enormous amounts of dust probably ended up in the atmosphere, which changed the climate for months, maybe even years. Lonar Crater is an astonishing spot in southern India, discovered almost 200 years ago. The pit lies within a large plain of basaltic rock left over from violent volcanic eruptions in this area, which happened 65 million years ago. Scientists even thought it was a volcanic crater at first, but soon they realized it was the result of a strong meteor impact up to 50,000 years ago. Look how specific basaltic rock is. And Lonar Crater is the only one formed in such a type of rock. There are trees all across the lower crater hills. And you can find a couple of interesting species over there, such as chinkra, peafowl, and gazelles. Plus, you can see many migratory birds flocking to the lake in the cold winter months. Yup, there's a lake there, and it's both alkaline and saline. In 2020, it surprised the local people because it changed its color to a rosy pink. It seemed unusual at first, but then scientists discovered such a specific color was the result of a growing population of a specific type of salt-loving microscopic organisms that produce such a pink pigment. This place is important for Indian mythology too, which is why there are multiple temples around the edge of the crater. Here's something really remarkable. The Ryugu crater contains an entire town within its inner ring. It's a small town in Germany. You can see the full result of this impact only from the air. The town walls highlight the inner ring of this crater that's about 0.6 miles, 1 kilometer, in diameter. Those are probably the dimensions of the meteorite that formed the crater. You can't distinguish the rest of it so easily, since the crater has been eroded away. That means natural forces such as rain and winds have changed it. In the heart of the Oumuamua Plateau lies the amazing Pingualuit Crater. The crater has its own pristine rainwater, some of the purest water you could find. It's not in any way linked to other lakes in that area, nor does it receive water from them. The water there accumulates from snow and rain. It's only lost when it evaporates. The depth of almost 900 feet is like a window to the crater's rich geological past. Scientists found different elements such as cobalt, nickel, and iron that helped them determine it was a specific type of meteorite where its parent body hadn't modified it in any way. The parent body is the celestial body from which a single meteorite or an entire class of them originate. Pingualuit Crater formed over 1 million years ago. There are even traces of stone set in a circular arrangement and rock shelters. People that used to live in this area would set up camps on the ridges of the crater. It was a good position for them to catch animals and stay safe at the same time. Australia is home to some of the world's most fascinating impact craters. In its western part, you can find the massive Wolf Creek crater. It's the world's second largest crater that lies on the edge of the Great Sandy Desert. More than 100,000 years ago, one meteor was most likely traveling at crazy speeds of 10 miles per second before finally slamming into the desert. Scientists discovered it in the middle of the 20th century, but local people had known about it long before that. They had many cultural stories about that crater. One was about two ancestral snakes who were so incredibly big they managed to form both Wolf and the nearby Sturt Creeks as they were making their way across the desert. One of those giants emerged from the ground, and that's where the big crater is today. It's dangerous to climb there since rocks are pretty loose, but that's where you can see some interesting animals like brown ring-tailed dragon lizards catching insects for lunch, or Major Mitchell's cockatoo harvesting seeds from the plants that grow on the crater floor. Another must-see crater in Australia is Goss's Bluff. It lies in the heart of the continent, sandwiched between the James Range and the McDonnell Range. It's a place of great cultural importance, so if you're visiting, respect signs stating which areas you're not allowed to access. A giant meteor slammed into our planet more than 140 million years ago. It was a really long time ago, so the original crater has been eroded through time. But even today, you can still see its core. A central ring of hills nearly 3 miles in diameter. This looks like you're on Mars, doesn't it? It's actually southwestern Algeria, and its famous Amguid crater. This one is relatively young, considering it's a result of a meteor impact that happened 100,000 years ago. This crater has an almost perfectly circular shape. Its center is unusually flat because of the type of soil at the bottom and the fact it's tightly compacted.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system. But that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bang! Or we could build a space station like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Ah yes, February 14th, 2000. Just a regular Valentine's Day, some flowers and some candy, the beginning of the new millennium, and a good day to make history. Near Shoemaker, which stands for Near-Earth Asteroid Rendezvous spacecraft, launched in 1996, finally got a date with asteroid 433 Eros. It wasn't about swiping right, but going around Eros and completing the first soft landing on an asteroid ever. Near almost didn't make it there, because an engine misfire from 1998 brought it into the wrong trajectory, and it missed the target. Yet, engineers decided to let Near do the circle around the Sun for one more year, and it eventually made it. Near Shoemaker was created to find, target, and stalk some smaller space objects for around a year and collect important data about them. This spacecraft got more than 160,000 pictures of the asteroid's surface, which helped with research in the years to come. Before then, some scientists took asteroids for just some random flying piles. Asteroid 433 Eros is indeed the smallest body in our solar system that got its own spacecraft orbiting it. At first sight, this asteroid seems like any other ordinary rock coming from space. Potato-shaped, rotating every 5.5 hours, the size of 2 Manhattans. For comparison, the biggest asteroid discovered is 383 miles across, while the smallest one is around 6 feet wide. Asteroids are actually some kind of leftovers that remain from the early stages of the solar system. The Sun, as we know it, began to get its shape when compressed gases and atoms started blending into a protostar. Smaller grains of debris and dust around the Sun formed into rocks, and as they were crashing into each other, ta-da! They formed even bigger ones. Objects that survive this chaotic and messy party are something we know today as planets and moons. Smaller bodies that couldn't get the status of a planet are called asteroids. They're too small to have any atmosphere, and their gravity isn't strong enough to shape them into a sphere, so they don't have conditions to support life. Most of them end up somewhere in between the orbits of Jupiter and Mars, and simply pass us by at a safe distance, but not Eros. It became the first of near-Earth asteroids, or NEAs. Since 1975, the closest Eros got to Earth was in 2012, around 16.5 million miles away, which makes it about 70 times the average distance to the Moon. It was discovered in 1898 and named after the Greek deity of love. You know, Eros, the arrows that he uses to make people fall in love with each other, the mess he makes with broken hearts. Yup, in Greek mythology, they call him Cupid. Among many other fascinating space discoveries is nuclear pasta. Not like one my grandma makes, true, but not that bad either. The recipe says you should 1. Wait for a star to reach a certain age when it's time for it to explode. And be patient because this could take maybe around 1 billion years. 2. After the explosion, collect its leftover neutrons and stir them until you get an extremely dense stew. Toss in some gravity to taste, and the last step, don't forget to bake it at 1 million degrees Fahrenheit. Nuclear pasta is definitely one of the weirdest meals on the universe menu, but also potentially the strongest material out there. You would need 10 billion times bigger force to shatter a place of nuclear pasta than to break steel. Scientists believe this stuff is that strong because it's incredibly dense, kinda like me. Picture this, 1.3 million Earths squeezed down and scrunched into the size of Toronto. Oumuamua is the first visitor that came to our solar system, something that scientists have been waiting for decades. This mysterious object was discovered in October 2017 and is considered to be a piece of some bigger body formed outside the solar system and torn apart during its journey. Oumuamua, which means scout in Hawaiian, is an elongated body that resembles a big space cucumber, definitely something unseen before. It has non-gravitational acceleration, and no one actually knows how it moves since there are no visible tails or any outgassing signs. Tabby's star is sure among the most mysterious in the universe. It's 1,000 light-years away, 50% larger, and a lot hotter than the Sun. In 2015, scientists noted that Tabby's star's brightness would dim down by as much as 22%. Big clouds of dust could be guilty of that, but this star is too old to have something like that. It's still not clear what could be causing this massive dimming. Nebula are huge clouds of dust, gas, and plasma that never stop dishing out surprises. They can change and take almost any shape: a fried egg, a space head, a diamond ring. A red square nebula is one of the most fascinating space objects. There is no explanation of how and where it came from. It's just a glowing and almost perfectly symmetric box in the middle of nowhere. Around 210 light-years away from Earth, there's the constellation called Lyra. That's where the Kepler 37 system is. Kepler 37b is the smallest planet in it, with under 1/3 of the Earth's mass. It's just a little bit bigger than the Moon. Scientists believe this is an airless and rocky planet similar to Mercury. Moving to Sagittarius B2, one of the biggest molecular clouds of dust and gas in our galaxy. It's located around 25,000 light-years from Earth and close to the center of the Milky Way galaxy. Research has shown it contains more than 50 different molecules, and one is sugary stuff that tastes similar to raspberries. Discovering tasty planets. Space is getting better and better. Fermi bubbles are two mysterious gigantic blobs made of cosmic rays, gas, and dust found in 2010. They hang around the central black hole of our galaxy, one on either side. Bubbles expanded below and above our galaxy over time, so they're now around 50,000 light-years across. No one knows how they got there, but one theory says they're related to the same black holes that occurred about 6 million years ago. Gliese 436b is one of the strangest planets out there. It's extremely hot, yet made of ice. This is a Neptune-sized planet that needs just a little bit more than 2 days to finish a full orbit around its parent star. It's assumed its surface has a temperature that goes up to 830 degrees, but the ice still doesn't melt since the planet has enormous gravity. Black holes are not always supermassive. IGR rests in the constellation Scorpius and is only 3 to 10 times more massive than the Sun, which probably makes it the smallest black hole discovered so far. NGC 3842, on the other hand, is something we picture when someone mentions a black hole. It's in a different galaxy and about 2,500 times as strong and massive as the black hole in the center of the Milky Way. Venus, the planet of superlatives. The closest planet to Earth, the hottest surface, reflective clouds that make it the shiniest planet as seen from Earth, the biggest number, 1,600, of volcanoes when compared to other planets of our solar system. Also, we're talking about the slowest spinning body in our universe that barely rotates at all. It takes 243 Earth days for Venus to make one single turn. This planet is so slow, you could actually walk faster before it makes a complete turn. Venus goes in the opposite direction from Earth, which is why sunsets there are in the east while the sun rises on the west side. 55 Cancri E is about twice the Earth's size with the temperatures of up to 4,900 degrees. Perfect conditions to turn carbon into diamonds. Yup, 1/3 of this planet is covered in carbon, which makes this diamond object one of the most expensive planets. Scientists who observe space changes in Antarctica see neutrinos at least once a month. Still, this one that struck our planet in 2017 was really special. It was the first one they could trace the origins of. They discovered it took 4 billion years for the neutrino to reach the Earth. It got to our planet from a massive black hole at the center of a galaxy that had been destroying all the matter surrounding it. Hey, welcome to the new neighborhood! So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed. And that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
the sun is rising, lighting up the trees, swamps, and massive plants of the Yucatan Peninsula. It's 66 million years before today, the last days of the Mesozoic era. This peaceful world doesn't yet know that a rock the size of a mountain is nearing Earth at a speed of more than 40,000 miles per hour. It looks like a fireball that's growing larger and larger with every passing minute. Soon, it already seems to be bigger than the sun. Dinos, roaming the prehistoric Earth, don't know that they have to run, hide, save themselves. Not that it's going to help. The asteroid slams into the planet with enormous force. It doesn't stop moving until it gets through the crust to a depth of several miles. The impact leaves a crater that's more than 100 miles across. Thousands of cubic miles of solid rock instantly turn into vapor. The crash sets off a series of natural disasters that erase 80% of life on Earth. It's the very asteroid that's going to finish off the dinosaurs. All the creatures close enough to see the crash don't survive for longer than a few seconds, so powerful the hit is. Closer to the impact crater, the ground is covered with thousands of feet of hot ash, grit, and rubble. 9 seconds later, and everything for many miles around, grass, trees, shrubbery, bursts into flames. What isn't burned down within the next several minutes after the collision gets flooded. In some places, tsunami waves reach a height of 1,000 feet. Earthquakes are starting to shake Earth like never before. Their power is equivalent to all the earthquakes that have happened on the planet in the past 2 centuries, if they were going off simultaneously. A bit less than an hour after the collision, a gust of wind whips through the area at a speed of 600 miles per hour. It flattens down everything that has been left standing and scatters debris for miles around. A bit farther from the direct impact zone, the skies start to darken dramatically. What looks like shooting stars is actually debris raining back on the planet. Glowing ominous red, they re-enter Earth's atmosphere and emit infrared radiation. During the first hours after the crash, the sky is almost totally dark. Later, it starts to get lighter, very, very slowly. For the next couple of years, it's something between a cloudy day and twilight. Lots of plants don't survive this dimness and the absence of sunlight. The ash stays in the air for months. That's why when it rains, the water is highly acidic. Fires keep raging. They produce tons of toxins that destroy the ozone layer, at least for some time. Earth is in for hard times. More than 30,000 objects that are circling Earth these days can potentially strike our planet. NASA considers around 1,500 of them potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. If one of these objects hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to all life forms getting wiped off the face of the Earth. Unfortunately, in our case, it's likely to be the second option. In 2004, astronomers discovered a huge asteroid nearing Earth. The first observations showed that the chance of the space rock hitting our planet was a bit less than 3%. The asteroid was named Apophis. It's more than 1,100 feet across and weighs about 20 million tons. It's supposed to streak across the sky exactly on Friday, April 13th, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. Scientists are almost positive that the intruder won't collide with our planet. What's more, they're super excited about the possibility to see this space object close up. And not only them, up to 2 billion people will be able to watch the asteroid pass with the naked eye. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 7 years later, in 2036. That's when life as we know it might no longer exist. Earth's gravitational pull is likely to bring the asteroid closer, and when it comes back almost a decade later, it's going to be on a closer collision course. Then, what would happen if Apophis or any other asteroid its size crashed into our planet? It would hurtle down to Earth at a speed of more than 1,000 miles per hour. Because of its huge size, air friction wouldn't be able to slow down the invader. Earth's crust would finally stop the asteroid. The impact would turn into vapor not only the space rock itself, but also a huge chunk of the planet's crust. The collision would flatten even reinforced concrete buildings many miles away from the crater. If the asteroid landed in the ocean, the tidal waves would reach several hundred feet. They would cleanly scrub nearby coastlines. Some debris would travel so fast they'd leave the atmosphere and start to orbit Earth. But most of the rubble would rain back to the planet. This would be heating the atmosphere until it got as hot as an oven. Wildfires would be spreading all over the world. Anything not sheltered underground would be cooked in no time. And then, for a year or even longer, Earth would look the same as it did after the asteroid hit it more than 60 million years ago. Ash, soot, no sunlight. A gloomy place. By the way, in 2015, astronomers noticed a 1,300-foot wide asteroid a mere 3 weeks before it passed alarmingly close to our planet. If its course had been a tiny bit different, people wouldn't have had any time to prevent the collision and save themselves. Does that mean that if a similar giant headed toward Earth, we would be doomed? No worries, people would still have a chance to survive. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could probably tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all more or less large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0. When a heavy spacecraft hurtles toward the intruder with one single goal, to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then, the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods worked, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that would somehow keep air and water fresh. Another option, which doesn't look realistic at the moment, is to go to space. It can't be low Earth orbit, about 1,200 miles above the planet's surface. Debris that would fly up at the impact could easily reach this height. This would probably leave people with 2 options: the Moon or Mars. Sadly, at the moment, we have no idea how to build a self-sustaining space colony. and there's not so much time left to figure it out. It's a clear night, and you're outside looking at the stars. The Milky Way alone seems overwhelmingly huge. You check on your phone and discover that the galaxy you're in at this exact moment is 100,000 light-years wide. For scale, 1 light-year is already a very long distance. For example, it takes 4.2 light-years to go from Earth to Proxima Centauri, which is the closest star to our planet other than the Sun. So, 100,000 light-years is way more than we normal humans can fathom. And that's just one galaxy. There's a whole lot more out there. Now, looking at this data, it seems pretty unlikely that we're the only life form out there, doesn't it? But how come we've never found anything else so far? Let's get one thing out of the way. Extraterrestrial life doesn't necessarily mean we're talking about little green people. It can also mean microorganisms, bacteria, and plants that can be found on other planets. The truth is, there's a big spectrum of possibilities for life on another planet. And taking into consideration that there are up to 50 billion planets in the Milky Way, it's very unlikely that we're alone in this big wide universe. And what does life on other planets look like? This is what we've spent years trying to figure out. Go ahead, think with me. A planet may be lifeless today, but it could have traces of organic matter or fossils, meaning that some life form was able to thrive there once. And it could also be that there are planets out there containing life with complex biochemistry, meaning they could have fauna just like we have on Earth, although probably not the same. NASA created a special science that is dedicated to studying life forms outside of Earth. It's called astrobiology. Ever since the space agency was created back in 1958, it didn't take long for it to start looking for extraterrestrial life. They quickly built an action plan. First, they needed to understand how life on Earth was formed, and secondly, how it could have formed on other planets. The first time NASA tried to look for life in outer space was in 1976. The Viking lander blasted into space, headed towards Mars. There were high expectations that humanity would find the first proof of extraterrestrial life. Unfortunately, the lander came back with images of a planet that looked barren and bleak, and scientists were extremely disappointed. Scientific conclusions on whether life could be detected over there were confusing. But hey, you need to know what you're looking for to find it, right? The failure of the Viking mission served to heat up debates amongst NASA scientists to define what life actually meant. And it also served to call their attention to a small but very important detail. Spacecrafts departing from Earth usually transport Earthling microorganisms and bacteria unintentionally, as they remain attached to the vehicle. It turned out that these bacteria could contaminate scientists' samples, so they needed to consider this. All of this made Mars expeditions take a back burner on NASA's short-term plans. There appeared a new priority-first question. What are the types and stages of life that space programs can hope to identify? Scientists might have encountered life on other planets, but they weren't able to identify it as life. That is why NASA began to study our own planet better. They studied everything, from ancient life forms that lived billions of years ago to living creatures that roam the planet today. They understood that the search needed to happen inwards as well as outwards. Let's take a look at the development of Earth's life from its inception. Imagine that this development can be represented as a ladder, or stairs, and each developmental stage is a flight of the bigger staircase. First, we would see basic chemistry, a soup of loose chemical elements like the ones we see in the periodic table. But they need to assemble themselves into more complex structures to be able to self-replicate, change, and evolve. This would happen in the second step, where we start to see the formation of microscopic organisms. In the third step, these cells combine to become multicellular beings, allowing for more complexity and variety. The step above sees species that can evolve big brains, enabling the use of tools, culture, and shared knowledge. That's where humanity is located. Looking at this ladder, one might ask, so what does it take for a multicellular organism to evolve into fully formed humans? This is what is called the Great Filter. It's a huge evolutionary jump that takes a lot of effort and the perfect environmental conditions for it to happen. And given that we haven't heard of any other extraterrestrial civilizations out there, it might be that we are the only ones that were able to make this jump. After all, how likely is it that we'll find life outside of Earth that is similar to us? That depends on how many planets there are out there in their star's Goldilocks zone, the area around a star where water can be liquid. And because stars come in all sizes and configurations, this zone is different for every star system. But that's not the only criteria we know for the existence of life. We usually look for three things to detect life: liquid water, methane, and oxygen. Water is what allows for chemical components to mingle and connect, forming multicellular beings. Methane is produced by the decomposition process made by bacteria, and oxygen is the byproduct of plant respiration. These are some of the telltale signs that the James Webb Telescope was programmed to search for. The James Webb Telescope has ambitious purposes that might revolutionize space science. Its top priorities are to detect forms of life by studying small galaxies orbiting the Milky Way. It will also look for the oldest stars in the universe, trying to gather data on the origin of the universe itself. That's huge! NASA is betting on two variables with this new telescope: a thorough scan on the so-called exoplanets, aka planets from outside our solar system, and the search for extremophiles, a type of life that loves extreme environments. Extremophiles were first discovered on planet Earth back in the 1960s at the bottom of the sea near the Galapagos Islands. Scientists found microorganisms living next to hydrothermal vents that dot the sea floor over that part of the world. Thriving in places like these with extreme temperatures over 700 degrees Fahrenheit takes a lot of resistance. I mean, can you imagine the heat? This discovery was a turning point for the field of astrobiology, as scientists understood that life could survive in extremely harsh conditions, similar to the atmosphere available in several exoplanets. But hey, life might turn up in our own neighborhood if we're lucky enough. Guided by the mantra, "Follow the water," NASA is launching two important missions inside our solar system that can contribute largely to the search for extraterrestrial life. You remember Jupiter, right? It's the gas giant that has a moon known as Europa. A few years ago, scientists discovered that Europa had an ocean hidden behind layers of icy crust. And there's even more. According to research, the water over in Europa is salty, much like the water we have on our planet. Europa is a big contender for the detection of life. But the Europa Clipper mission is not aimed at trying to identify this. Rather, it will orbit the moon and gather as much information about its atmospheric conditions as it can. The other moon-bound mission is the Dragonfly, an octocopter that will explore Saturn's moon, Titan. The launch is programmed for 2027 and will only arrive in Titan's orbit around 2034. It will sample and examine a series of promising sites around Saturn's icy moon. And who knows, find some new information on ET life? Let's see what happens. But I'd say we've never been closer to a huge discovery than we are now. Something is happening on the red planet! Scientists believed that they knew nearly everything about its atmosphere, but a NASA rover has discovered something unexpected. There's more oxygen on Mars than they thought, and it behaves in weird ways. In the spring and summer, oxygen levels go up even more, and no one knows why. Now, you might think that when there's oxygen in an atmosphere, it's mostly because there's life somewhere around, like trees on Earth that produce oxygen through photosynthesis. But on Mars, it's not that simple. Non-living processes can also create oxygen, so we can't surely say that its presence means there's life on Mars. Mars has long been one of the main candidates when it comes to looking for signs of extraterrestrial life. back in the 90s, scientists announced they had spotted potential proof there could be life on Mars because of microbes they had found in a meteorite that had arrived from the red planet. It looked like they had found fossils of bacteria. They actually stumbled upon tiny crystals of magnetite in the meteorite, which they believed could only have been produced by living organisms. It was such a mind-boggling discovery. People were excited, but many were also skeptical. It didn't prove there really was life on the red planet. Maybe there was life there a long time ago. The meteorite is thought to have originally formed on Mars billions of years ago, and to have landed on Earth thousands of years ago. Skeptics soon started to pick apart the evidence and eventually found some things that didn't make sense. For example, these magnetite crystals. No one could be sure how they formed. Why do they have to be bacteria? Some research has shown they could be the result of shock waves. Recently, the Perseverance rover has collected a couple of new rock samples from the Jezero crater on Mars. The theory says that about 3 billion years ago, before the red planet lost most of its atmosphere and basically just dried out, there was a big lake with a river flowing from it in that area. Whoa, what a great environment for life! Perseverance studied mud samples it had found on the bottom of the evaporated saltwater lake. Scientists were amazed to see a record number of sulfate molecules, something we usually find in mollusk shells on our home planet. Such organisms evolved a couple of 100 million years ago, but maybe there was a time when some of their space ancestors lived in water bodies on Mars. Mars has weaker gravity than Earth, which means these weird species could have got really big there, way bigger than their Earth cousins. Gravity plays a significant role when it comes to limiting the size of organisms. Bigger organisms need more energy to move against gravitational forces, but the creatures that may have lived there long ago are just a mix of hypothesis and our imagination, something that's still really hard to prove. Meet the Curiosity rover, another robot NASA is using to explore Mars. Curiosity has been in charge of measuring the composition of the atmosphere of the red planet for many years now. The rover has discovered that it mostly consists of carbon dioxide and a little bit of nitrogen and argon. The atmosphere of Mars has only 1/10 of 1% of oxygen, since, as far as we know at the moment, Mars doesn't have plants that could produce enough oxygen. But Curiosity has also discovered anomalies no one can really explain. It's found out that there are spikes in oxygen levels in the Gale crater during the Martian spring and summer. Every year, oxygen levels go up and down in unpredictable patterns there. What's even more interesting is that the oxygen spike is similar to a seasonal spike in methane, which is a gas we often associate with life on Earth. No wonder scientists are scratching their heads and wondering if there's a connection between the two gases, and if they both come from the same source on the Martian surface. Is there something big that breathes there? Come on, we'll be happy even with some small space worms in the soil. There's a type of salt called perchlorates in the Martian soil. Some scientists believe perchlorates might be responsible for the strange spikes in oxygen levels. But like with most things we know about space, it's just a theory. Also, scientists think that perchlorates breaking down in the Martian soil release oxygen too slowly to cause and explain the sudden increase in oxygen levels. One of the suspects is hydrogen peroxide, which is like water's unstable cousin. Hydrogen peroxide forms when sunlight breaks up carbon dioxide and water vapor in the Martian atmosphere. It can seep into the soil and stick to particles underground, which means it forms some kind of oxygen storage tank. Some data even show there are pockets of subsurface water in the Martian soil that may be hiding enough dissolved oxygen to actually support life. But even if the hydrogen peroxide could stay in the soil for millions of years, it would still only explain a small part of the increase in the level of oxygen. So you can't blame it for the whole thing. We can also take a look at an old experiment from the 1970s, where scientists found that moistening the Martian soil caused it to release a lot of oxygen. However, They did this experiment at a warmer temperature than the planet's average. And again, it doesn't explain how the oxygen spike keeps happening every year. None of the clues we have seems to fit the case. Mars may not have enough of its own oxygen, but it's possible to make this gas there. NASA conducted a small experiment where they tried and managed to produce oxygen on Mars. MOXIE is a device that can make oxygen on Mars. It managed to produce enough oxygen for an astronaut to breathe for 100 minutes. This awesome device worked in pretty tough conditions, at night or during the day, at extreme temperatures, and during the crazy dust storms the red planet is known for. Despite all this, MOXIE still kept up with producing high-purity oxygen. MOXIE is a clever device that can make oxygen on Mars by taking in carbon dioxide from the planet's atmosphere and heating it up to incredibly high temperatures. This allows the device to pull oxygen atoms from the carbon dioxide and produce breathable oxygen gas. If we want to use MOXIE to make enough oxygen for human missions to Mars, we need to make a bigger version of the device. But if we make it bigger, we might have trouble keeping it at the right temperature and making sure it heats up evenly without breaking. The ultimate goal would be to create an oxygen device that could continuously support a human mission for about 400 days. With a bigger version of MOXIE, we'd have enough oxygen to support crew members and even propel a return rocket to our home planet. When you see the dusty red surface of Mars, you can't say it's a place that hides liquid water underneath. Some say it's too cold for water to exist on Mars anyway. But there are stories that there could be a hidden world of liquid water, just like subglacial lakes in Antarctica. And to find out more, we might have to drill down about a mile beneath the surface. Unfortunately, it's not going to happen anytime soon. But in the meantime, scientists have been using a spacecraft called Mars Express to study radar reflections around the southern pole of Mars. The reflections seem to indicate there could be liquid water, and the planet's interior might be keeping it warm. But some claim it might just be rock. We hope there are underground lakes on Mars because it would be a perfect spot to look for life. After all, scientists have found bacteria living in subglacial lakes on Earth, but we don't know for sure how deep they are or if they're just small veins of water in the ice. Only time and more exploration will tell.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, Scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn, or Saturn on steroids. That's because J1407b has a colossal system of rings. they're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What a view! Discovered in 2017, KELT 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K2-18b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K2-18b orbits a red dwarf called K2-18. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K2-18b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K2-18b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K2-18b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K2-18b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K2-18b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it. Without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K2-18b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide, or simply DMS, in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by photoplankton in the oceans. The fact that we're picking up hints of DMS on K2-18b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot, with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean, with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water-ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K2-18b, because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations.